pretty involved. Before I go over any of your homework questions, let's just go through these real quick. Okay, you got a prism. Do we have a lateral area formula for prism? No. How do you find the lateral area? Take off the what? Bases and find what's left. Probably rectangles. Okay, so take off the bases. All right, so area, all areas but bases. Everyone good? Most likely rectangles on a prism. All right, and I can't say this enough. All rectangles aren't the same dimensions. Take each rectangle one by one tomorrow, find the area, add them up. Then how do you find surface area? Lateral area plus now how many bases on a prism? Plus the two bases, yes. Lateral area plus the two bases. Whatever they end up being. Okay, they could be triangles. They could be, we did a couple of problems with hexagons. All right. Cylinder, that is a formula you're going to need to know. Lateral area of a cylinder. Pi dh. Surface area. Think about it. Hey, think about it this way. I don't want you to have to memorize all these formulas. You should, if you know the lateral area, no memorization needed the surface area, because what are you adding on to the lateral area? Two what? Circles. Two circles. You're adding on two circles, and you know by last unit, the area of a circle? Pi r squared. So I'm hoping that's not one you have to memorize. If you know the lateral area, we should know the surface area. Pyramid, I don't have a formula for you. What are all the faces on a pyramid that aren't a base? They're all triangles. So you're going to do number of triangles times 1/2 BH. And then for the surface area, you're going to add on whatever the base is. What about cone from yesterday, lateral area? Pi r. L, what's the L stand for? That's the slant height. That's on the cone, not inside. That's not the Mission Impossible height. And then what are you adding on to the cone? It's lateral area to get to the surface area. One circle. To me, tomorrow, this is it right here. Those two should be the only thing being memorized. And then you add on two circles, and you add on one circle. That's it. Those are really the only two formulas you need to come rocking and rolling with tomorrow. And then the surface area, you add on two circles for the cylinder, or if it's a cone, you add on one circle. Any questions on those? None will be given to you. Thomas?
For the cylinder and the pyramid, the H represents?
Height of the cylinder, height of the pyramid. Well, no. This H right here is the height of one of the triangular faces, which would be the slant height. Okay, good? Not the height of the pyramid. And this is the height of the cylinder in H. The H in the cylinder is the distance between the two circles. Anything else? Let's turn it over here. I'll go over as many as you need me to. All right, we do have a busy day on tap, just to let everyone know here. We're probably going to go right to the bell, which we usually don't do. But all right, but let me first start with any of the homework. Let's get it through. And if some of you guys noticed, I changed up the answer key last night to just put the answers because I didn't need people just copying the work. It would have done you no good. Go ahead, Anthony. 10, everyone. Take a look at 10 so you can help me out as well. Okay, here we go. The Pyramid Arena in Memphis, and that's an actual place, by the way. Pyramid Arena. It's a square pyramid, which means what about the base? The square. The base is a square. And the edges of that square are 600 feet. And the height is 320. Estimate the number of glass on the sides. The sides, meaning what am I actually looking for? I didn't come out and say it, but I'm looking for lateral area. I didn't look for the base, the lateral area. So this is a pyramid. How many triangles does it have if it has a square base? 4 triangles. 4 times 1/2. What's the base of one of those triangles? 600, because that's the base of the square, right? So times 600 times the height. So here's what my triangle looks like. I have 600. I'm looking for this right here, which is another name for what on that pyramid? Slant height. Yeah, slant height. But I was only given height. That's not slant height. If this was slant height, I'd literally write in the word slant. Okay, this is the Mission Impossible height. All right, so what do I do with this to get the slant height? We do Pythagorean theorem. So everyone ready? I do 320 squared plus, anybody remember what comes next when you make this right triangle? I have the height, which is 320. Anybody remember how to find this length there? Half the base length. So if the base was 600, what's half of it? 300 squared will give me my slant height squared. And then I take that number, plug it in to my lateral area, and type everything I need into the calculator. Height plus half the base equals the slant height, remember, in a pyramid. Height plus half the base equals your slant height. Anthony, we good? Next, let's go. I'm going to keep rolling. Nika, go. 5. All right, what are we tackling? Oh, the old hexagonal prism, yes. And this was surface area. Okay, surface area. How many triangles does it have, Nika? I'm going to do lateral area first. How many triangles does it have? 6 triangles times 1/2. What's one of the bases of those triangles? What's the base length of one of those triangles? 4 times the height of one of those triangles. The height on one of those triangular faces, already given. 10? So ready? Right there. See what I have written here? That is the lateral area. Everyone else, lateral area. Right? But it said surface area. So now I need to add in the base. What shape is the base? That's a hexagon. Okay, I got to find the area of a hexagon now. All right, and the way we did that, if you remember, we split it up into 6 different triangles. Right? We split it up into 6 triangles. 1/2 base times height. So if I take one of those triangles right now, if I take one of those triangles, the base is going to be 4. You with me so far? The height now we got to do a little work for. Okay, the height now, see this angle here I formed? That's 360 divided by 6, which is 60. The height cuts it in half, so what's this angle? 30, and it's across from not 4, but 2, because it cuts it in half. So what's the 60 across from then? If 2's across from the 30, what's a 2 radical 3? Now, whatever that turns out to be, I am going to plug in as plus the base. We okay there? It's tough when it's not a square. I know, it's tough when it's not a square or a triangle for the base. Others, let's go. Yes, Kevin. 14. What are we looking at here? Yep, a bunch of these. Not even say a bunch, but you're going to see a few of these tomorrow. Oh, everyone calm it down. There we go. Let's try that again. All right, here we go. What's the top part? That's a pyramid, but I'm not going to do the surface area of a pyramid. Why am I not going to do surface area? What can I not glide my hand over? The base. So basically, I'm just going to do lateral area of the pyramid. So lateral area, here we go. Basically the triangular, how many triangular faces does this one have? 4. So 4 times 1/2 base times height. Take one of the triangles right now. What's the base length? 60 times the height on one of those faces. 50 already given. So there is part of it done. Okay, here's where some of us struggle now. Now we have to go to the prism. Usually a prism has 6 faces. Well, what can I not, how many faces can I glide my hand over? Only 5 of those faces, not 6. And all 5 are not the same dimensions. What's the bottom one? 60 by 60. And I am not multiplying that by 2 because the top 60 by 60 is covered up. What about the right and the left? 60 by 180. And I can multiply that by 2. I can actually multiply it by more, but I'm just showing you here 60 by 180, the right and the left. So I'm going to multiply that by 2. The only ones I have not taken care of are the front and the back. So plus the front and the back. What are the dimensions of the front one here? Also 60 by 80. So yes, I could have multiplied that by 4, but I just wanted to show you the front and the back are 60 by 80. The right and the left are 60 by 80, and the bottom one is 60 by 60. Take each darn rectangle individually. Don't just assume all 5 are congruent because that's probably not the case. And then I'm going to add those 2 together. We are right there, Captain. We're good? Anything else here? Let's keep it going. Or anything, because this is it. By the way, we have a shortened period tomorrow. It's shortened by 7 or 8 minutes. I can't remember. So as soon as you get in, we're taking the quiz. There's not going to be an opportunity for, what about this formula? What do I do here? That's right now or today after school. Okay, we got a drill first period tomorrow. That's going to take a little bit. So each class tomorrow is shortened by 7 or 8 minutes. It's still enough time to take the quiz, though. It's not a test. It's a quiz, so it's still enough time. Anything else? We're going to be all right with one of these tomorrow. Can't do the surface area of everything. Got to figure out what's covered up. And the one tomorrow, I don't think is that bad. All right. Anything else on the homework, questions in general? Because I may not see some of you after school, so this will be the last opportunity. We're done? Okay. All right, then. So tomorrow it is. Make sure also, not just your formulas. Hey, faces, vertices, edges. I'm going to give you a figure, how many faces, vertices, edges, and be ready for a couple cross-section questions. You can look at, I want to say, check me, Emma, there, page 5. Is that where we had the homework the first night? That had the 5 cross-section questions? Page 9? All right, somebody help me here. First night homework, was that page 8? Okay, page 8. All right, so a couple cross sections. What do you got, Caleb? Yep. The trick is faces plus vertices minus edges always equals 2. That's the way you can check yourself. Faces plus vertices minus edges equals 2. John? That's just showing you that. Here you go. Yep, good question.
Is RSVT like the base?
Well, it's a face. Wait, this right. So SVT, it's showing you that there's, instead of one big face behind here, there's 2 faces. There's SRT and there's SVT. That's what that dotted line showing you. Yep. It's just separating all the faces for you. Okay. Anything else? Good questions, guys. Yes, Emma, go ahead. I would never ask you that at all because I have no idea. One, I have no idea what it is, and 2, I can't cut it up into something I do know. So I wouldn't have you do something like that. Just this type of question. Okay. Anything else? Okay, just a reminder, tonight's homework due Thursday. Okay, due Thursday. We're going to go into volume now. All right, we are going to go into volume. Calc's ready to roll. Good news about this portion of the unit, I don't want to say every, I think almost all the volume formulas are given to you. Quick question for you kiddos. We've been doing surface area a lot on the outside. What's volume now? We're going to go inside the figure. Yep, that's space occupied inside the figure. Let me get my notes ready to go so I know what the heck I'm doing, huh? Okay, so that's space. Only definition here, occupied inside. Space occupied inside a polyhedron. All right, first off, before we get into any volume formulas or any figures, anybody want to pronounce this mathematician's last name there? I don't know. Cavallari? I don't know. Cavallari? All right. Cavallari's principle. Sea dog? Sea boss? Yep. All right. I can't remember if our boy makes an appearance tomorrow on the quiz or not. I know he's definitely coming on the unit test. Is just going to blow minds. I can't remember if he's on there tomorrow or not, but okay. All right, so Cavallari's principle. Ready? Here we go. Cavallari's principle. Here's what it says. If you have two figures that have the same height, listen up. Hey, two figures that have the same height. And when you take a cross section, remember our cross sections. So here, if I take a cross section, it's going to be in the shape of a square or a rectangle. Everyone agree? And I take a cross section of the other figure who has the same height. Those cross sections have the same area. So those two rectangles have the same area. Those two squares have the same area. Their volumes will be equal. Notice here, see how this is standing straight up? We got a little leaning tower here. Doesn't matter. Doesn't matter. Because they both have the same height. And when I take a cross section and calculate the area of it, and if they're the same, they have the same volumes. Okay? The best example is right down here with these pizza boxes or cardboard boxes, whatever. All right? You got the one that's neatly stacked, one that's a little bit leaning, and then you got the hot mess over here. All right? Some of you may relate to that one the best. All right? Moving on. They all have the same volume. Why do they all have the same volume even though they look completely different? One is they all have the same height. Two is you take a cross section. Does everyone agree? Well, every one of those rectangles will have the same area. So they all three have the same volume by his principle. All right, everyone see that? It's got to have the same height, and when you take a cross section, it's got to have the same area. To even solidify this more, take a look at these figures. That's a what type of prism? What type of prism do I have here? Triangular, and I just have a rectangular one here. They have the same volume. Why? Why do they have the same volume? Well, first of all, they have the same height. When you take this cross section of this triangular prism, what shape is it? It's a triangle. And what shape is it for the rectangular prism? A rectangle. If they have the same area, even though they're two different figures, if they have the same area, these prisms have the same volume. Everyone all right with the principle there? Same heights, same cross-sectional area. Okay? Even though they're two different figures. Even though they're two different figures. Okay? Everybody good? We go over this because it popped up one year on the Regents exam, and kids were like, Cavallari's principle. And I was like, yeah, remember the 2 minutes we did that on May 21st? Okay? I try to stress it a little bit more with different diagrams now. Questions you want to ask there? All right. Let's go to a prism now. How do I find how much space is inside a prism? I'm not going to tell you. You're going to flip over to your formula sheet right now. Get used to using it. It's very, very good for this volume part. Everyone see general prisms? What's it tell you the volume of a general prism is? Big, no, not BH. No, big B. Big BH, right? Big B. H. I don't think it tells you what big B represents, huh? Big B represents, yes, the area of a base. Area of one of the bases. And then H, height of the prism. Height of the prism. Okay, real quickly, everyone, I have 3 figures. I want you to identify the base. Rectangular prism, what was our rule for base? Anybody remember what was our rule we're going to follow? However it's drawn, the top and the bottom. So for instance here, when you told big B would be the area of this rectangle here. That would be big B right there. All right, that would be big B, the area of that base. What's the base here? Name the base here. Triangle. So whatever the area of that triangle is, sorry, I'm doing it in yellow, that's big B. Maybe I should do it in a different color. Base for this one. Hexagon. So you would have to find the area of the hexagon, and that would be big B. Okay? That's disgusting, that outline of the hexagon. I don't care at this point. Cylinder. Flip it over. Here we go. Flip it over. Cylinder. That's also on there. Here we go. 12. Area of a cylinder. Volume of a cylinder. Pi r squared h. Isn't that still big BH? Everyone see that? That's still big BH. Why? What's the base of a cylinder? Circle, pi r squared. It's still BH. All right, your formula sheet does you a little solid, though, and solid, but never mind. That's what we're in. That's what unit we're in. I'll just continue on. That joke was about as good as some of your grades. Moving on. Number 1. Volume of the prism. I love it when some of you guys just act so miserable. It makes me so happy. Makes me so happy. Big B, what's the shape of the base? Triangle, here we go. 6. Ready to go, Nika? Yes. All right, triangle, area formula for a triangle. 1/2. Now this is a right triangle. What do we know about the base and height of any right triangle? It's the legs. Go ahead. So I'm going to do 1/2 times 8 times 15. And can you give me the height distance between those two bases? 8. There it is. So again, right here, 1/2 8 times 15. That's big B. And then 8 is H. And we end up with the volume to be 480 meters. Welcome to volume now. Cubed. Cubed. The units are cubed in volume now. All right, great basic problem, right? Let's raise the level now. We got a pool. The volume is 1,080 cubic meters. So that's the volume. Length, width, and depth are in that ratio, 10 to 4 to 1. Find the dimensions. What do you do with the 10 to 4 to 1? Put X's with them. 1,080. Maybe a button you've never used on your calculator before here. What is that? What are we multiplying together here? Length times width times height. So 10x, because you said put x's with them, 4x and 1x. Length, width, and height of the pool, rectangular pool. All right, algebra skills taking over. Good times back in the day. Oh boy, here we go. Look at the suspense building. 30, good times. 4. Not here. Good times on 4. 20. Yep, here we go, Claudia. Ready? 10 times 4 times 1. 40. X times X times X. X to the third, X cubed. Got it? What's your move here now? What's your move here now, everybody? Oh boy, building up once again. This is fun. 26? Nope. Yes? Yeah, hi, Jack. Yeah, don't try to do anything crazy yet. Divide by 40. Divide by 40. What do we get? 27 out of that, Jack? 27 is equal to x cubed. Do we know what to do from here? Take the what? Not the square root. Cube root. All right, let's talk calculators real quick. 2 different ways you could get to a cube root. You can hit your math button. And some of you guys check me on this. Some of you guys can go alpha window. I don't know. Is it on there? Alpha window? Yeah, Nam. Yeah, he knows his calculators. Yep. Alpha window. Or some of you just got to go under the math button and it'll be there. So cube root of 27. And it ends up being 3, but we did not win any prizes yet. Why not? That's just x. It said find all the dimensions. So x is 1 dimension, 3 meters. So I have 3 meters. How about the other 2 dimensions for me? 13, the other 2 dimensions? 30, 10 times 3. And the last one there, Emily? 4 times 3, 12 meters. Great job. Good job, everybody. Anything else? All right, let's go. This is not, told you it's going to be a longer day here. Big Jed, here we go. He bought the old generator. Generator can go 2 hours on 1 liter of gas, everybody. 1 liter of gas. The gas tank on the generator is a rectangular prism with those dimensions. If he fills the tank with gas, how long will it run? And I gave you a little conversion here. And I'm sorry that didn't turn out to be an exponent, but 1,000 cubic centimeters is 1 liter. What do I need to do first with this rectangular generator? Find the volume. And how do I know it's volume and not surface area, lateral area? 2 different ways. One, you're filling it with gas, correct? Inside. And what's the conversion? Cubic centimeters. So we know it's got to be volume. All right, so we'll go. How are we going to find the volume here? What are you guys multiplying together here? Oh, 6. What are we multiplying together? We can go BH. Yeah, we can go BH here. So what's the base here as it's drawn, Nico? What's the dimensions of the base as it's drawn? 15 and 20. And then what would be the height then if I use 15 and 20 as the base? 10. Yep. $13. What's my volume of this generator? 3,000 cubic centimeters. All right, guys. So where do we go from here now? I know it has 3,000 cubic centimeters and it runs 2 hours on 1 liter of gas. Is there any way you can find me how many liters it can hold? How can I find? I have 3,000 and every liter is 1,000. Let's take 3,000 divided by 1,000. So this can hold 3 liters. Everyone good so far? A lot of calculation. This is where I need to go here. This second half of the unit is doing a little more than finding the volume. All right, how long is it going to run on? Well, we know what? 2 hours for a liter of gas, and I have 3 liters. So it's going to be 3 times 2. This bad boy run 6 hours. This is exactly what I'm looking for, this second half of the unit. Anything? All right, let's go cylinder then. Excuse me. Volume of the cylinder in terms of pi. Okay, use your reference sheet if you need it. 15, volume of a cylinder. Plus. You're better than that, Hendrik. Pi r squared times the height. There we go. $17, a little plug and chug time. Pi, radius here. 5, half a 10. And what about the height? 7, there you go. In terms of pi, 16 in terms of pi, what's my volume? Still waiting, Thomas. Still waiting. You're better than this.
Yes, sorry.
Thank you. Okay, the old thermos. Remember those days? Anybody? Maybe you guys, maybe they never did it when you were out, but had the lunch box with the thermos in it. Yeah, those days. Yep. Okay. Yep. All right, we're on the same page now. Yep, good old days. Sure, you can remember the character that you had, and yep, the good days. Lunchbox. Flip the little spigot open for you. Yep. Good times. Anybody want to reveal the characters they had or the shows that they had? Okay. Star Wars. All right. Nice. All right. Well, our thermos, obvious shape of a cylinder. We're going to fill it 1 inch to the top with coffee. The height is 12 and the radius is 2. State to the nearest hundredth the volume of the coffee, not the thermos, the coffee. The volume of the coffee. Well, we put the coffee in the cylinder. What shape is the coffee going to take? The cylinder. So we're going to do pi r squared times the height. There is one little change we're going to have to make, though. What's going to be the radius of our coffee? 20, nope. How about 12? Radius of our coffee? Yep. Still 2.5. Now here's the thing, height. Remember, we're doing the volume of the coffee, not the thermos. Thermos is how high? 12, but we're only filling the coffee 1 inch below, so the height of the coffee is going to be 11. Everyone all right while we're putting in the 11 there? We're taking the volume of the coffee, not the thermos. Hundredth. 700th. Great job, as always. 35 weeks in. 27. Hundredth.
215.98.
Thank you. All right. We're all right, because this next one, you're going to have to be on your A game for this next one. I think. Oh, the old barrel of oil. I give you the diameter and the height, and there are 231 cubic inches in one liquid gallon. Everyone see that conversion, huh? 231 cubic inches in a liquid gallon. Determine how many gallons are in the barrel. Gallons are in the barrel. Okay, so cylinder again. So pi r squared height. Yep, going to do a quick calculation probably for the radius. 3. Radius.
11.
Yep, you got to divide, what was it, 22.5 by 2? Yep, 11.25. And how about the height, Emma?
33.5.
Yep. All right, we are not done with the problem here once we find the volume. So I'm going to write out the entire volume here on my from my calculator. Just make sure we match up here. I might have done a calculation incorrect myself, but okay, everyone ready? That's how many cubic inches I have. And we are told that there are for every 231 cubic inches is 1 gallon. How many gallons do I have? And I know people get all freaked out. Do I multiply? Do I divide? Do I multiply or divide? Set up a proportion. Ready? 1. If you don't need to, don't do it then. 1 gallon. How many cubic inches in 1 gallon? 231 cubic inches. Equal to, what do I have? Gallons or cubic inches? Cubic inches. It's got to go across in your proportion from the inches. So I'm going to place this, our answer, right here and figure out how many gallons. And then once you set this up, do you end up dividing by 231 or multiplying? Dividing. Okay, so if you're unsure, set up a proportion. Put the conversion right first, 1 gallon and 231 cubic inches, and make sure the units are across from each other. Yeah.
Would the answer when it's in gallons, would that still be cubes
No,
now?
because this, remember, it says 1 gallon, right? Your conversion says 1 gallon equals 231, not 1 cubic gallon. And 21 to the nearest tenth. How many gallons do I have? What do we have? Why do we have inches? It's just no, it's just gallons. Look at the conversion. Liquid gallon, that was it. It wasn't liquid gallons cubed, so just 57.7 gallons. Okay, I'm going to save this. I'm going to save number 7. We're not done yet. I'm going to save number 7 for Thursday. I want you to work on number 8 right now in your group. Find the volume of that one. So you're going to have to cut it up because I did not give you the volume of an L. Try to cut it up. See if you and your group can find the volume. Try to cut it up either with a horizontal or a vertical line to make it into 2 prisms. Okay, where'd the 6 by 2 by 8 come from? So this is this whole thing right here, right? 6.
Oh, it'd be 4.
Right, wouldn't be 6, right? Yep. So just change that 6 to a 4. It is 76. Correct. And with volume, you don't need to worry about stuff on the outside, what's covered up, because you're just filling up the inside covered up. Okay, you guys, as soon as you come in tomorrow, you'll get the quiz. I'll be here after school if you want to work on anything. This homework, volume homework's due on Thursday. I have 679.